All right. That was a fight and a half. I think we're actually live. Um, hey Alexa, trigger live show.
Sending that to it.
So this is a little bit of an adventure, so to speak. I don't know what settings are working. The PC decided to hard crash right before the live show, so we'll see how things are. Cheers, guys! Welcome back to the channel. I think I'm gonna keep looking off camera because I have no idea where we're at and what's working. So we'll see. I just wanted to get things on the go. Happy SuperCon weekend to all you SuperCon aficionados out there. It was 3 years ago today. 3 years ago yesterday, I was on stage at the Hackaday SuperCon myself, accepting third prize for my gas sensor for emergency workers. So, yeah, crazy ride that was. But got a couple things to do just as a shakedown tour here in the shop. Got Mike's, Tick Mason's. Cheers, Armando. You're still first to the stream. Apologies if there was a few bad starts to the stream. I'm not sure whether any of those got out on camera or not, but hopefully the audio and the video are half decent. I want to thank Charles Lohr, who provided me his song library to use here. Sorry, Charles, I don't have the IDV3 data up on the screen yet. You're supposed to display not only song and title when you're doing live streams, you're supposed to tell people where the music came from. I haven't done that, but I think we have tunes in the background. Hopefully they're not too distracting. And hopefully the audio is coming across a little better on this setup. I'm not using the headset audio anymore. We're going to see how this goes and give it a go here today. Anyway, yeah, it's just a shakedown. Test out all of the equipment. Tech Mason, one of my subscribers, gave me his key fob here, and he asked that I put it through the ultrasonic cleaner. And, well, we'll see what's wrong with it. I'm not sure whether it needs to go into the ultrasonic or what, but I'm pretty sure we can fix it. He says it's dead. It's completely dead. It's not working. So CR2032 battery in here and some electronics. Let's just test that battery first. When in doubt, always check voltages first. Always, always, always. We'll see if we can fix this thing. I'm pretty sure we can. These key fobs are usually impact damage, so we've got 304 volts DC. Do I have an LED right handy here? Where's all my LEDs? Some infrared ones. I would like to just check and make sure that that isn't just a surface charge, and let's see if it craps out under load. Oh, it does. 1 volt. Yeah, it's not recovering too terribly well. The battery's not the best. CR2032. Let's see. I kind of believe he would have already tried a battery in it. I would think. Let's look at this under the microscope. Let's see what we're up against. Let's go to USB microscope. So there's our push buttons. That's what he wanted cleaned. I'm not sure whether that's what needs to be done or not. I don't think so. Look at this board. This thing's spotless. That solder joint doesn't look very good. That doesn't look good. But there's no contamination on this, so I don't think ultrasonic cleaning is going to help it. Let's have a look at the other side. There's one of the main micros and some passives. 315, 357. I wonder if that's our frequency output. That might be valuable shortly when we go to test this thing. 315, 357. I wonder if it's around 315 megahertz. That sounds about right. Usually these key fobs, these remote keyless entries, are right anywhere from 300 to 400 megahertz. Let's have a look. Oh, come on. Don't drop things. Might grab my other microscope. Let's grab the other microscope. Let's just take a quick look. Let's see what we're up against. There might be more to this story. And we can use the big microscope here. That's what I got it for. This is the one that Strange Parts Scotty reviewed and recommended on his channel many moons ago. How's the audio? Is the audio okay? Between the tune and my voice level and stuff, let me know. Let's go to HDMI micro. And okay, so this is under my HDMI microscope, and audio is great. Thanks, Armando. Appreciate that. That's helpful. Does it come across all right when I kind of mumble like this? The headset was way too hot. Okay, this is what I wanted to look at. I'm going to try and... This is what I spotted under the USB microscope. It's definitely a little bit clearer on here. If we zoom right in, as we can with this, that looks like a very bad situation. Can I turn the light down a bit? Yeah, the audio exposure is kind of making it hard for you to see. I can see it a little bit better through the optics, but not much. It's about the same. But that looks... Oh, come on. I need more light than that, Eric. From my eyes. That looks like a damaged solder joint. That does not look right. Okay, so let's get a better... Let's do the overhead. That's what we're working on. So let's clean it up and just take a look. My alcohol jug is empty, of course. I'm going to go grab it. Let's fill that up. These little alcohol dispensers are handy dandy. This is just 70% isopropyl. Plenty good enough for this job. Use isopropyl for cleaning and removing water from all kinds of things, but for electronics it's just wonderful. So you just take a Q-tip, get that nice and wet, go back under the hood, and not that one. Let's focus a little bit better. Get that where you can see what's up. There. Let's see. Is that what we think it is? Because that would be awful convenient if that is all that's wrong with this. And it sure looks like it. Yeah. Well, it's really tough to say, actually. Even with my better view than you guys get from rendered from YouTube. I can't. Oh yeah, there it is. There it is. You see that black gap? Yeah, that's hosed. That, if I can find something to pokey bit, we can probably even see that move under the microscope if I manipulate it. Now, it's still pretty rigid, but that is most definitely cracked. Now, how are the others? How many more are cracked like that? So, what is that? Is that one of our main power connections? Yeah, it is. Looks like it's cracked on this side too. Yeah, and this side. It's cracked right all the way around, which is normal. It's a big heavy battery hanging off of there. That doesn't overly surprise me. So you can see the inside here is separated. So I think if we solder those up, let's get the soldering iron warmed up. I think if we solder those up, we'll be in good shape. We'll fire up the 898 and the Unger. Make sure this silly USB thing is not gonna be touching anything hot. There we go. Alright. Should be in good shape. I think we can fix this. What do you guys think? It's been so long since I've done any live shows. This is kind of fun. Get to, nope, not that button, not that button, not that button. Hey, 5th time's a charm, yeah. Let's just go through and investigate all the other things while we're in here. There's one right there. That one's not the best either. Those are seemingly fine, but that one by that switch is definitely not great. Yeah, that one is completely hosed. That is most definitely. How's that coming across on video? Let's see if we can zoom in. Show you guys what up close and personal cracked solder joint looks like. So you can actually see it's completely lifted on the one side. Yeah, that is completely right through, but not all the way around. That one's just cracked. On the other side we could see that it was all the way around, which breaks our connection. But I'm not saying that this is gonna be the root cause, but this is where we're gonna start. We'll start by fixing this stuff. Let's see, anything else? Anything near that micro? We didn't look at the micro yet, did we? Let's just take a spin around. No, nothing. Looking good. Looking good, looking good. You can even see some solder blobs underneath that cap. But yeah, I think we'll start there. It's easy to pop this thing back apart and keep on working on it. McBong's Lab, cheers, buddy. Yeah, this, I think we'll be able to fix it up. Okay. I'm just going to, where's my overhead? I'll go right here. Let's grab, what do we got? Yeah. Just clean this tip a little bit. Should be fine. Alright. Let's go back under the hood. Let's see if we can fix that up. Okay. Back to the other side. There we go. Actually, I'm gonna put a little bit of, need some more sticky tack stuff. Mine's getting all gone hard. I just use, like, people also call it blue tack, but I have the gray stuff. It works good for in cases like this when you've just stuck your work to your microscope. Actually, it's not working in this case. It let go right away. We'll get that good and hot and go all the way through. We're going to see that solder penetrate. And then if we flip this over, we're probably gonna see it went right through to the other side. No, not hardly. You know what? There we go. Let's give that a bit more time. I always got to remember that you guys, I have a bigger field of view through the microscope than you guys do. Alright, that should be. Yeah, that's pretty good. Definitely good enough for this case. This use case, anyway. Alright, let's hit this. And hit this one. Are we on camera? Not bad. I have, I don't know, easily 40% more visual area than what this HDMI camera can see. There's nothing wrong with that one, but we're going to touch it up anyway. Come on, hold still. Yeah, that's not great. That's not great, but it's better than it was. Alright, let's see. How'd we do? Now, wasn't there... Where was that other one that was just a little bit funky? We got those main power ones. Oh, what the fudge? Look at this. That ain't right. Oh, can I get that? I didn't do that either. Okay. Oh, there's your problem. Check this out. That's not coming across. Let me try again. Oh, look at that. Oh, there's your problem. Tech Mason, did you beat the crap out of this thing? What did you do? Oh, man. One too many beers when it wasn't working, decided to start hammering on it. Alright. Well, I wondered, because those power connections, although bad, I have definitely seen worse. But this explains what's going on with at least that button. That is completely severed. Okay, that's easy enough to fix. Easy enough. Lead-free solder. Yeah, most things are in the last many years. But not the solder I'm putting on there anyway. Ah, crap. I'm trying to move the microscope where I can actually solder this, but where you guys can see as well. Alright, how do we do? Alright, that should be good enough. That is why she no worky. Let's see. That one, and there's that one. Mucho gooder. So, typically, when I see something like that, I don't... What the hell? Is that even... Is that one even worse? I was gonna say, typically when I see something like that, I assume all the others have the same problem. Is this even hooked up? Yeah, it's just the way the switch is. But we're gonna touch them up anyway, because if they're not a problem now, they will be. It's all the same vintage of solder. I just don't know what... This might be the panic button that never gets used. Good enough. Let's find One more button. And that one looks fine too. Big gob on the board. Don't do that. It doesn't matter. It's not. Didn't go through the mask. Oh, there must have been a test point there already. Didn't even notice. Okay. Now we're gonna go ahead and do the other side. And that. What do you guys give it? What's our odds of success here? I give it solid 50%. Alright. Let's touch this up. I'm having trouble. It's ugly, but that's what happens when you keep poking at things. For a sense of scale, you gotta remember, like, this is tiny, so anything that looks like a big old mountain under the microscope that you keep poking at and prodding at generally is probably fine. And I've learned to stop myself sooner rather than later. Like, there's actually nothing wrong with any of these connections. Come on. Actually, that one there might have been something wrong there. Take that back. I did, right before the solder flowed, I did see a spot that looked a little wonky. But we'll see. We shall see. Anybody else building anything cool this weekend? You guys are a quiet bunch. Oh, come on. My blue tack stuff is not tacky. Just touch up that. That's just a test point. Got a little gunky on it. Not gonna worry about it. Not gonna worry about it. Okay. I don't suppose there's an LED on this thing anywhere. There wasn't one when I tried it before. What do we got? Negative, down, positive, up. No smoke, no explosions. That's a good sign. Maybe. Should we see if it works? Let's go back to the overhead. Not building anything, messing around with Raspberry Pi. What are you doing with the Pi? Pies are always never-ending fun. Always cool things you can do with those. Okie dokie. There we go. Let's put this back together. I don't think we're going to need it apart anymore. I don't believe so. As long as this truck's not parked anywhere close by and starts screaming and honking and carrying on, we should be able to start pressing buttons here. Okay. Yeah, a nice satisfying click to each of those. But are they working? We need a different tool to find out. One thing we can do, I've never had success with this, but we can see if the RF energy is picked up by the scope. And let's turn channel 2 off. No. As it shouldn't, because, well, a good scope probably shouldn't get overwhelmed with a bunch of RF. Or it's simply not working. I don't know. We're going to find out. Okay, let's try something different. Let's break out a different tool. You guys seen these before? I haven't done videos in a long time. This is one of my wife's insulin injector cases, but in it I keep these. This is an R820T software-defined radio. It's a DVB TV tuner, but we're repurposing it as a software-defined radio. And we should, in theory, be able to fire up a computer, and we will sniff the RF, and if it's working, let's go slightly off camera with that in the meantime, Eric. If it's working, we should be able to get a visual display. SDR, same one as yours. Yeah, I have a pile of them. I have one in every bin of everything. Anywhere I go, I have, like, you can see there's some other radios in there too, but there's a whole bunch of software-defined radios in there. $3 o'clock, okay. This thing better be fixed. Alright. I'm not setting it up on the stream PC, sorry to say. Yeah, so we're gonna have to settle for a camera aimed at a screen. But I think it'll be fine. Let's go this side. Oh, did I just hit the power button with that? I think I did. I think I did. Brilliant. Good job, Eric. Actually, I think it might have been the magnet. I don't know, I'm gonna have to watch the replay. It might have been the magnet. The bottom of the antenna has a magnet in it. And they might be using Hall sensors or something up in there. Alright, let's try it again. Should we try this again? Alright. This time we won't let's just lay our antenna over here where we're gonna get all kinds of freaking noise and carry on. That'll be fine. Let's fire up my old SDR Sharp, which I just keep in Dropbox. Okay, there we go. We're at 313 megahertz ish, and if this is working, it should splatter the band somewhere around there, and it's not. Okay, let's see. It might be. Does anybody know what the frequency Toyota Key Fobs run on? Let me know in the chat. Let's try mine. Okay, so this is mine. There's lock, unlock, lock, unlock, and you can see it splattering the band pretty good there. And this is dead. Alright, remember that battery was a little wonky. Let's swap that out before we go any further and get disappointed by, like, I'm pretty sure we got some of it working, but to tell further we'll have to pop it apart. Alright, what do we got? 2032. We got a 2032. I think so. Maybe. 2032s. What do we got? 2030. Yeah, I don't even know. I don't even know. I know I have one thing that takes those, and that's the locator light I use for my RC aircraft and drones. So maybe that's what I got those for. Alright, press button. Nada. Okay, well, at least we know it's a new battery. Now we can go maybe check different frequencies. Anybody find the frequency? Dead battery. Yeah. Hey, Dustin. Cheers. Okay. Well, that's not working. Let's go scan up through whilst pressing buttons. 380 meg, 300. This close, the spurious offshoots, like the radios in these aren't that good, so we should have all kinds of noise, and there's nothing. What up with that? That's 500 meg. Is there some of these running 900 range? Let's try right around the 900 megahertz. Does mine even splatter the band up at 900? No, it doesn't. I never know with SDR, like this close. It's 970, 980. Does anybody know? Toyota, what frequency are you on? That's not a gig. I'm guessing it's probably 400 meg. Did we fail? I think we failed. But it was 300 on there, right? Yeah, 315 megahertz. Thank you. That's what we saw on... That was right on what I assume is the oscillator, or the crystal. Oh, there it is. Ha, what do you know? It's just a lot weaker than mine. There's 315 megahertz. That's 314.82. And there we go. I should have paid attention when I was reading that. I read it right off the chip on the live stream, didn't I, guys? What an idiot I am. So 315, 5. What did you write in chat? 315 plus or minus 2.5. Yeah, right on the money. Right on the bloody money. So if we go and change the contrast a little bit, make that a little bit more visible, you can even turn the gain up just a smidge. Why not? Obviously, like, that antenna isn't exactly the best for, it isn't exactly tuned, but there we go. There's constant button holding, and we have taki-taki. There's unlock, 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 panic. Deck Mason, I hope your truck isn't close by. Alright. With that seems awfully weak though, eh? Like, that's not what I would expect. I would expect significantly stronger on the waterfall. What do you guys think? It seems awfully weak to me. Does that thing go to an antenna on the board? Let's just take a quick look. Or is it just self-contained? Where should we do this? Let's do it under the USB microscope. Might be alright. See if... Nope, nope. Nope, nope, nope. And there's our oscillator or crystal or whatever. So maybe that's as strong as it gets. What do you guys think? It's clearly working, and it wasn't before. I'll say I cheated, and I did go to 300 through 400 range on the SDR before to make sure it was dead before I decided to fix it. So I don't know. I think that's fixed. It's worth trying anyway. It's alive. What do you guys think? 315, 433 seem to be the two most common. Yep, thank you. Hack 1 RF. Yeah. Prius is 312, and maybe that's a harmonic. Try further down. Actually, that's a good thought. I don't think. What was the other frequency on here? What was the other label on that? God, my memory is shot today. 315, 357. Okay. 315, 357. So it's somewhere between 315 and 357. That's a good call. That might actually be a harmonic, and it might be further up the range. We can go ahead and put this thing together. Oh, sorry guys. You can't see. Let's do everything from 315 up to in the neighborhood of 357. See if we see anything else. That's a good call. That's a really good call. Might actually. So let's do 316, 17, 18, 19, 20, 21, 22, 23, 24. Oh, hold on. Let's go back. Was it still? Make sure it's still working. Okay, it is. 16, 17, 20, 23, 26, 27, 28, 29, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46. No. Wow, that seems ultra low power. And there's 357 megahertz. So back down, we were at right around 315, right? What's going on? Did it die? Oh, there it is. Well, it's working. It's just not crazy powerful. But it is definitely talking. Which it wouldn't have before, because those buttons were completely broken off, as you guys saw. So there's panic, 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 panic. Well, at 300 megahertz, you don't need a lot of power. So the 300 megahertz, that'll have some punch, right? Like, that'll go a long way. So I think we're gonna call it. I think we're gonna take it out and give it a go. 315 to 433, blah 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 blah. Yeah, yeah, it's not my car, Jason. This is the Tech Mason's truck, and yeah, mine was beeping outside when I was testing the lock feature. Yeah, I don't know. That's significant about the noise floor. What do we get? We peak right to minus 4 dB thereabouts, so that's probably plenty enough to reach out there like hundreds of feet. At 314 megahertz, yeah. I think, yeah, I think we got it. Yeah, alright. Methinks we're done with the SDR for now. What else should we fix today? That was my one big one, because I owe Tech Mason. He keeps furnishing me with more and more goodies, helping me out with network equipment and stuff this week. Craziness. So we're gonna say that's done. Oh, I do have one thing I'd like to do. One thing quickly. I want to test some LoRa project stuff this week, preferably. In here I have some, hopefully, some LoRa radio stuff. Actually, I'm just gonna move it off camera so I don't think there's too much sensitive stuff in here. So these are Adafruit LoRa long-range radio modules, and I'd like to get this set up. Initially, when I set these up, there's no code or anything on my GitHub yet, because what I thought I was going to be doing with these was something significantly different, something commercial. So I didn't share what I did. But I think we're at the stage now where I might just do some YouTube videos on it. And it might be fun to play with these. If Eric can plug the freaking battery in. Okay, So that's a lithium polymer battery, and this is a lithium polymer battery. What I want to do is just get these set up, and then after the stream I'm going to charge them for some extended time. And we should have what I set these up to be. Here, let's use them. This is the master. This one's, either one can be program master or slave. These are just the Adafruit feather wings with the OLEDs and built-in LoRa on the main board. Actually, I can show that easier on this one. The LoRa module is right here, the wireless radio module, and it's just a backpack over on top of the existing, I think these are STM32 micros. Jeez, it's been so long since I built these, I don't even remember. Gosh, it's been forever, guys. So that's the LoRa module. It's 32 U4s. So these are the 18 mega 32 U4. So crazy, crazy powerful little microcontrollers from Adafruit. So what I've got is, if it'll focus somewhat, I have a battery indicator, and then I have the TX and the RX online. Being that this is the slave, this one is showing the TX is online, the RSSI value, which is our radio link value, and then a counter that's always counting up. And on the other one, you can see we have similar info, except we can't focus with beans with the C920 that close. But the RX is online, the RSSI is showing -35. Well, it's just because they're right on top of each other. But that's the 400 megahertz antenna that I made. Or are these 900? Geez, I can't even remember. I'd have to stretch that out and measure it, but I think these are 915 megahertz. I guess we could fire up the STR to find out, but it'd be easier just to look it up. But anyway, the counter runs. So these are completely linked and bidirectionally talking. So if I go ahead and pull the plug on the other one, I should see this one go no connection. And that is just wonderful to tell that you have a good solid data link, you're talking, and the information is being passed, as well as a nifty little battery level indicator, which is actually part of the Adafruit code, as well as a, if I remember right, this wire needs to be fed from the positive there, and if not, it kills the onboard regulator, if I remember right. No, not that one. I clearly don't remember right. Which one kills it? Where is it? You put that. I think you ground it. Yeah, you ground it to shut it off and even kill the onboard regulator, which is pretty cool. But yeah, that works really good. Yeah, because I've got nothing plugged into the positive. And then I've just got this going to my ground. So yeah, ground it to kill power to it and conserve the battery. I think it kills the LDO as well. And then let it fire up. And wonderful. They talk to each other. I'm going to charge these up and do some range testing with them. Test them out. Initial range testing I tried before was ridiculous far, like crazy far, even in an urban environment here in town. So I may give those a go, but for now I'm just going to charge the batteries up and make sure everything is ready for this week. And I think that's it for today. Maybe catch up on the chat real quick and then I'm out, I think. Yeah, I think we're pretty much caught up, guys. I hope you guys had a fantastic week and a fun weekend. Hopefully you're building something cool. I hope the live stream came across well. I'm going to review the replay and see what kind of tuning we can do to change things and make things even better, but hopefully the audio and stuff is a little bit better than before, and we've even got some tunes and stuff. So cheers, guys. Have a fantastic rest of your weekend. Happy SuperCon weekend to all the SuperCon entrants, and hope you all did well in the Hackaday prize. Cheers, guys.